Start. Good afternoon. Today we are going to discuss about a case study of a fatigue failure on drive shaft. Okay, there are 4 types of failure that usually occurs in any material, particularly of ferrous materials. One is ductile, brittle, and fatigue and creep. So here we are speaking about fatigue, which because the fatigue fracture occurs majorly at high speed machines. Okay, high speed machines. So here the name is given as a drive shaft. So usually drive shaft that is used in any type of automobile will be running at high speed. So this is the you can say it as the fatigue may be the higher possibility or probability of occurrence for the failure. Okay, so let's go deep.
Introduction. The diameter will present with the proportion of the system of wood. It is made of low alloy steel grade 4340. It is broken while sailing along the western Canadian coast. The presence of fuels stresses at the presence of ice recent Frederick fracture.
So as I mentioned earlier, this may be one of the reasons, but the major probability of getting failure of this type of high speed shaft is fatigue. Okay.
You could see that if you take an investigation, it was found that the filter radius present at the fatigue origin was smaller than the one provisioned by the design. Although the shaft has been pinched and tempered, it actually hardness did not have the optimum value of the long life fatigue strength. You could see here, we can see that the damaged parts of the broken shaft.
Okay.
These are the damaged parts of the broken shafts.
So we have to test an analysis to verify the problem in the
Right.
We can do we have to check the chemical composition and mechanical properties and the mechanical conditions to check when coming to chemical analysis, if we carry out we have to do chemical analysis in that if we took the grade ASF is 430 but the range 0.38 approximately the both broken shaft and the broken shaft and the grade ASF are both
Same broken shaft and the standard one are the same.
so there is no change in chemical analysis. And when it comes to tensile strength, the whole specimen and the original specimen and the broken shaft has same proportion, so there is no change in tensile strength. And coming to mechanical properties, according to the Rockwell C scale, its grade is broken shaft is attained up to 30 as C, and the original approximately it's come to 30 as C, so no change in the shaft. It comes to microstructure examination. Typically, microstructure of the submitted shaft is tempered mortar steel. This is a tempered mortar steel, and it is the assumed structure of that material.
So going to the stratigraphic analysis, we can see that the red iris indicates where the crack had started and had propagated to the blue marks which is being given. So from this we can understand from where the crack has started and through which it has propagated. And here coming to this picture, it is of high cycle fatigue, that is smooth beach marks. So we can see the cracks here. So then moving to the low cycle fatigue, we can see the bench marks with more structures. Here also we can see the cracks. So if we zoom in, like it will be more visible. We can see the cracks which is for low cycle fatigue. So here we have the cracks which are being shown. So this is for like low cycle fatigue. And then this is the final fracture. So we can come to a conclusion that it has a rough finish, and it also has there are absence of benchmarks, and there is a slant more to the
When it comes to conclusion, the shaft mark because of the rotating bench figure. The radius was 1.58 compared to the required design is 2.5 mm. When for the grade for ASI 4340, the optimized resistance is 45 HRC, and the fracture indicates the shape periplane at the fracture radius and the high cyclic fragment mechanism. Spherical resistance initial limit has been proved.
So here, in short, we can say that as I said before, this is the drive shaft. So it is already, you can see drive shaft which is required in any automobile will be running at high speed, that is around about 500 rpm. So they are the high speed machines, right? So this fatigue where shows is that it's occurs in the high speed machine. So it's because the drive shafts will one time run at the high rpm, other time in the low rpm. So this changes. This is the type of load. So running high rpm and low rpm is the type of load. So this changing in load makes the to get fracture. The main type of fracture, as I already discussed, is the fatigue fracture. But here, in order to avoid this, we have to improve the endurance limit.